Hi and welcome to the GraphQL Apollo Server and MongoDB video. Very quickly before the start of the video, if you want to stay updated with the modern web development courses and content releases, please subscribe to my newsletter. The link is in the video description. Happy coding and learning. In this one, we're going to talk about the basics of these three technologies. So if you don't have any prior knowledge of GraphQL, Apollo Server, or MongoDB, then this video is going to be a perfect fit for you. So let's talk about what it is that we're going to cover throughout this video. In this video, we're going to talk about what GraphQL is, why do we need it, how do we get started with it, so the setup, and we're going to talk about some queries and some mutations as well. So don't worry, we're going to explain everything. Now, then we're going to also say, okay, how Apollo Server factors into this world of GraphQL, and how do we persist our data with our MongoDB. But first things first, we need to understand what GraphQL is. And this is the GraphQL website, and I believe it explains it really well. This is the start of the website, the top part of it. So whenever we're working with GraphQL, that means we're working with backend. So if I'm talking to an API, if I want to request some data, that's always going to be backend. So once I request some data with GraphQL, I need to specify what type of data I want to request. So that's going to be our very first step, which is describe your data. So our data is going to be in the form of a project. Project has three different members. So it has a name, it has a tagline, and then it has contributors. So name is going to be of type string. Tagline is also going to be of type string, but please pay attention to the first letter, which is capital. But then contributors is going to be an array or a list of users. Okay, so that's the description of my data. That's the blueprint of my data. Now, let's move forward. So this is how my data is going to look like, right? But I just want to select the tagline from my data. So the project name is GraphQL, and I ignore the name. I don't need it. I ignore the contributors, and I specify exactly what I want, and that's the tagline. And the data that I get from this API call is going to be exactly that. It's going to be a tagline. All right. So what is the difference between this GraphQL and REST API? So GraphQL is a different technology. REST API is a different technology. REST API, what it basically does is it allows us an interface in order to talk to some sort of a backend, which is like a database, and then request some data. But the problem with REST is most of the times it either overfetches, or it receives too much data, it gives us too much data, or it underfetches. It doesn't give us enough data. And it is very difficult to specify exactly what you want. All right. And that is the problem that GraphQL is going to solve. So GraphQL is not an API like REST. GraphQL in its own is actually a language. It's a query language. So you query for data, you say exactly what you want, and the good thing is you're going to get exactly that. Nothing more, nothing less. So that's the difference between GraphQL and REST API. More on this when we actually dive into what it is that we're going to do in this video. Now, what is Apollo Server? Here I have opened up the Apollo Server website. You can go to apollographql.com. And Apollo is basically a set of tools for working with GraphQL. It makes our lives so much easier if we use Apollo Server to work with GraphQL. Now, Apollo actually has two different APIs. One is for server, which we are going to use in this video, which is called Apollo Server. And the other one is Apollo Client that is going to fetch and manage data on the front end. That's not the focus of this video. We're not going to talk about that in this video. And Apollo is a great tool if we want to have some help with connecting with our databases in order to increase our performance and caching. And Apollo is the most popular option if you want to work with GraphQL. All of this is very, very simple. So I'm just going to jump in and I'm going to get started with these. So we're going to get started with an empty VS Code folder. And from here, the first thing that I want you to install is actually the GraphQL extensions. And the extensions are very simple. There's just two of them. The first one is GraphQL language features. So this is the first one that you need to install. And the second one is this GraphQL syntax highlighting. So this is the first one, GraphQL language feature support. And the second one is this syntax highlighting. And after these two extensions, you're basically done with this extension part. So we're going to get started by creating or initializing an npm project. So I'm just going to jump into the terminal and I'm going to say npm init y. I'm just going to say yes to all of the questions to get started with this as quickly as possible. So let's just hit enter. We're going to wait a few seconds and there we go. So what this generates is going to be a very simple package.json where we don't have anything in here aside from the name, the version, and that's it. So we don't have any dependencies, any dev dependencies, nothing. So the first thing that I'm going to do here is we're going to actually change the type of the module. So type, it's going to be changed from common.js to actually type module. Now, what this is going to do is this is going to allow us to use the ES6 syntax, the import export syntax, as opposed to the require function. All right, we're going to use that. So this is a newer method. All right. Now, for project dependencies, what we are going to install is going to be, the first one is going to be nodemon. So I'm going to say npm I nodemon. This is going to allow us to refresh our server without having to like break the server up and then reload it again. So it's just going to do, it's basically going to update our server automatically with the new information. So that's nodemon. The second thing that I'm going to install is going to be GraphQL. Let's hit enter. And let me save this. I should just install. I made some changes in the package.json, but I didn't save that. So that's why I need to reinstall this a second time. So now we have our GraphQL and nodemon, both of them installed. And the final thing that we need to install is going to be npm I at Apollo /server. Let's hit enter. And after this, we should be good to go. All right. So we have our Apollo server version 5, GraphQL is going to be version 16, and nodemon is going to be version 3.1. There is going to be one more thing that we're going to need to install, and that's going to be Mongoose for our MongoDB database connection, but that's going to come later. For now, this is just going to be enough for us. So in here, within our project, what I'm going to do is I'm going to create a folder that's going to be our index.js file. So the entry point for our server is going to be this file. And within the index.js file, we try to create a very simple server. Now, this server is needed in order to establish the connections between GraphQL and MongoDB and Apollo server. And I'm going to come back to this server in a couple of minutes and we're going to change it. But for now, let's just go ahead and let's create this. But before doing that, we need to change the script because we want our server to be up and running with nodemon. So I'm going to say nodemon. Now, nodemon has to basically direct itself or target the main entry point of our server. And that's going to be our index.js file. Since both of them are within the same directory, I can just say index.js. And I'm going to change the script from test to start. So if I say npm start, that's going to start our server. Let's save this time and let's close that. So how do we create a simple server in Node.js? That's very simple. We're going to say import create server. Create server. We import this from Node HTTP. Now, this node colon HTTP, this is a newer syntax, and it is a little bit more performant, and you need to actually use this syntax whenever you're trying to create a pure, whenever you're trying to use any package that belongs to native Node.js. All right. So the first thing that I'm going to do is I'm going to define on which port my server is going to run. This is going to run on port 3030. You can change that to whatever you want. And let's create our server. So const server, we have this create server function that we just imported, or method. This is going to require a request. Request comes from the front end, and then we send a response based on what kind of a request it is that we have received. So we're going to say if request dot URL is equal to /, which basically means our home page. If user wants to load up our home page, and the request method is equal to get. So get method is an HTTP method. It is going to allow us to send data and nothing else. So we just load some data on the front end. We just send it to the front end. All right. We don't do any changes. We don't allow user to do anything else. Just load the data. So if this is the kind of request that we have received, the response is going to be response.end. I'm going to say simple node server. In just a few minutes, we're going to change this to our Apollo server, but I just wanted to show you how a simple Node.js server is created. How do you actually make it up and running? So if you don't have any prior knowledge of this, this is actually a very good thing. So we need to have our server listen on our port. So let's pass in the port. And whenever server is listening, we need to run some sort of a anonymous function or a callback function here. And this, you could do whatever you want in here. I just want to print something to the console specifying that our server is actually running correctly on our specified port. So I'm going to say server is running on port. Where is my port? Oh, I need to convert this to backticks. Server is running on port, and here is our port. There we go. So what seems to be missing? We don't need this. Let's save that. There we go. So everything should be up and running. Let me just go ahead and say npm start. Let's run this, and there we go. So you can see we just created a very simple server in Node.js, and it says server is running on port 3030. So where is that port? You can just say local host. Oh, I shouldn't just search for local host. There we go. It is 3030. Hit enter, and there we go. It's a simple node server. All right. So this is our very simple node server. I'm going to change this to work with GraphQL. Now, the thing with this is we could use, there is a library that is unfortunately not maintained for the past few years, and that's the Express GraphQL library. So if you have any prior knowledge of GraphQL, that's going to be the library that you will be familiar with. But since the documentation actually says don't use it because it's not maintained for a very long time, we're going to actually jump in and use Apollo Server. So Apollo Server is maintained better, and it works seamlessly with GraphQL. And in order to do that, let's just go ahead and let's actually create a very simple server with Apollo here. So I'm going to comment everything out. I'm going to keep that for your reference, but then we're going to jump and we're going to create an Apollo server. All right. And this Apollo server is going to be able to basically act as an HTTP server, meaning it is going to be able to handle all HTTP details for us. And creating an Apollo server is extremely simple. So the first thing that I'm going to import is going to be Apollo Server. We're going to import it from Apollo Server. And what is this Apollo Server? This is basically the main class from our Apollo Server package. So this is going to be the core component that's going to handle GraphQL requests and response. And the second thing that we need is going to be start standalone server, and this is going to be a helper function that is going to create and start a basic HTTP server for us. All right, so we imported that from Apollo Server standalone. Next up, we need to import a couple of more things, but then we need to create them in order to import them. So for now, I'm just going to try to actually set up this server. So for any Apollo server that is going to work with GraphQL, you need two more things. So one of them is an idea that's called a resolver. And the second thing is, which is the most important thing in GraphQL, that is the schema. So at this point, we have not defined any schema. So let's go ahead and let's actually define a schema, which is the most important thing you can do in GraphQL. Now, in order to define your schema, I'm going to tell you what schema is. So you need to put it in a specific folder. That's a convention. So here, I'm just going to create a new folder and I'm going to call it data. So the job of this data folder is to give us a dedicated directory for all data related logic in a GraphQL project. So what we want to do is we want to keep data access separate from schema definitions and server configuration. So index.js is our server configuration, but we want to have our schema definitions within our data. So the data folder is going to contain our schemas. It's also going to contain our resolvers, also our mocks and fixtures and models. Where in this video, we just talk about the schema, and we're going to talk about some resolvers. I just want to keep it as light as possible. So within this data folder, the first file that I'm going to create is going to be called schema.js. Now, why is this called schema? What is a schema? So a schema is basically a blueprint for our data. That's exactly what we saw in here. So the first part of this, describe your data, that's our schema, right? So what do I mean by describing my data? So I'm specifying exactly what the type of my data is going to be, aka the blueprint of my data. This is going to be the big thing that is going to decide this entire project. And the way this schema is actually defined is like this. So we're going to say const, there is going to be a specific name for our variable. That's going to be type definition. So I'm just going to say type defs. Now, since the schema is going to be very long, we are going to have a lot of different types and queries and mutations in here. It's easier if we just break it into multiple lines. And what feature of JavaScript we can use in order to break something in multiple lines? Into multiple lines. That's the backticks. So that's why I'm going to use backticks here. But this, keep in mind, this entire thing is actually one big string that is going to be parsed by our Apollo server. Apollo server has the ability to parse all of the queries that we define in here. Now, let's go back to the website. So what did the website do? The website said that we need to specify a type for us first. So let's go ahead and let's do that. But the name of the type that we specify, the name of it, it has to be capital, right? So the first thing that I want to do in here is I need to specify a type, but I don't want this to be a project type. I want it to be a type of query. So generally in GraphQL, you have two things that have counterparts in REST as well. So a query type in GraphQL is the same thing as a get HTTP method. So the job of this is to just fetch data. So when I specify a type query, what I mean is I'm trying to fetch some data. Now, HTTP methods over REST API, they have other methods as well. Like HTTP has other methods to update our data. And those methods are going to be translated into mutations for good reason, right? So if you mutate something, you change it. You could change it by adding some stuff to it, or you could change it by removing some stuff from it. So nonetheless, when you change some data, you mutate it. That's a computer science term, right? So Our update method in HTTP, our post method, delete method, these are actually mutations in GraphQL. And I believe they make more sense in GraphQL. So query is we just fetch some data. Now, this is just to get started with our server. So I'm going to keep everything simple. I'm going to say, I'm going to be able to query for something. So that thing could be hello. So user, this hello is something that the user can query for. It's like our tagline that we saw in the website. Now, I need to specify what type of data this specific query can handle. Well, the type of this is going to be string. Now keep in mind, string has a capital S. So what did we do so far? We just said, okay, we have just one query. So our backend can handle only one call to fetch data, and that call should be specifically to hello. If it is to anything else, it's not going to work. And this is the beauty of GraphQL. It is very, very specific to what it is that you want to do. So now that we have created that, our type definitions, right? We have type definitions in TypeScript. That's exactly what we have in GraphQL. We specify the type of our data, much like we specify the type of our variables in TypeScript. It's the same thing. So those are our type definitions. Let's import, before using them, let's try to import these. So we have type defs, and we need to import them from, this is going to be inside of the data folder, and that's going to be schema, but you need to add that .js as well. All right, so we have imported that. Now, if we want to send something back to the client, how did we do it with our Node.js simple server? We use some sort of a method, right? So here it is. We use this end method, res.end. You could use res or response.send. I just said end because that is going to end everything here. But nonetheless, we used a method. Now, in GraphQL, in order to send some data back to the front end, we are going to use a method. But that method is called a resolver. So a resolver. And a combination of a resolver is going to be resolvers. So resolvers are going to be functions or methods that are going to resolve the query that we receive from the front end, and they're going to send back the data. So that's the function. Why should this be a function? Since our types, they are normal objects. They look like normal objects. Why should our resolver be a function? Why can't this be an object as well? Because objects are easier to work with. Now, the problem with an object is an object cannot calculate data. It cannot calculate logic in order to understand and predict next steps. But a function can do it. That's why we use functions, right? Functions can handle several different things at the same time. But objects, they are just a data structure. They just specify the type of our data. They cannot mutate our data. They cannot change our data. They can't do anything. So we need a function in order to do something. That's why it's called a function. It does something. And what it is that we do, we send some data to the front end. And that's exactly what a resolver is going to do in a GraphQL server. So how do we create a resolver in Apollo? Now, some things that I'm about to do here, they are very specific to Apollo Server and its integration with GraphQL. So this is very, very important if you want your server to work correctly. So we're going to create a variable. We're going to call it resolvers. There we go. And this resolvers is going to have, for us, for this video, this is going to eventually contain two different members, right? So the first member is going to be query in order to query for data. The second member is going to be mutation, which is going to be like the post, update, and delete methods in HTTP servers or HTTP methods that change the data. So the first one is query. The job of this query is to just go ahead and query some data. So this query is, the format of this is an object. An object is a very, very powerful data structure data structure and JavaScript. It can handle several different things. So we can have a function inside of here. We can have some simple data inside of here. So it's a very good way to structure our data, and that's it. So I said I have a query for hello. So let's go ahead and let's handle hello. So if user sends a request to hello in order to query some data, which is called hello, I should send some data, and the type of that data should be string. But what is that data? We didn't specify it. So let's specify that. I'm going to say for hello, I'm going to run a function. See, I'm going to run a function. And that function is simply going to say, hello world GraphQL. And that's it. So you can see hello world GraphQL is a string, and that's what our hello is going to handle for us. So far, our first resolver has been completed. It is a query resolver, but the setup for Apollo Server has not been completed yet. So we imported two things. We have our resolvers and we have our type definitions. But there is no central point to combine our type definitions with our resolvers. So far at this point, this resolver query, it doesn't know what our type definition is. It has to know that, right? Because as I said, GraphQL is very specific. So what is this hello? You need to have, is this a query? Is this a mutation? What is the type of this? So we need to specify that. So here I'm going to say, this is our server, and we're going to grab our Apollo server, and Apollo server is going to accept an object. The first member of this object is going to be our type definitions, and our type definitions are going to be handled by our resolvers. Now, this is not a good practice to have your resolvers logic inside of your server configuration. We're going to extract this to our data folder because that's the job of the data folder, to contain the resolver. And it should be separate. So this is server config. It should be separate from our data logic, right? But since I just want this to be up and running, I'm just going to put it here. But later on, we're going to extract everything to its own file. So next up, let's go ahead and let's make sure that we can make sure our server is up and running. Much like the server.lesson, we have an equivalent of that here as well. So I have this const URL that I'm going to just destructure at the same time. I'm going to grab my await start standalone server. And to this, the first thing that I'm going to pass is going to be our server. And the second one is where the server should listen to. So the server is going to listen to a port, which is, again, 3030. Let's save this. And finally, I'm going to print something to the console. So I'm going to say log, and that's going to be server ready at URL. There we go. Very good, right? So let me just close the server, clear everything up. So let me say npm start. Okay, so we have our type definitions, type def. The problem with this is because we did not actually export our type definitions. So let's go ahead and let's say export. Let's save everything. Let's come right here. And there we go. It says server ready at this. So what we could do is we could just copy this, close that server and paste it, hit enter. And now you can see it says Apollo server. And there seems to be something going on. And let's wait for it until it shows up what it is. So I'm really zoomed in. Let's zoom out of it. And there we go. Congratulations, you were able to basically set up an Apollo server. Basically, this is a sandbox or a playground that is going to help us work with our GraphQL queries and mutations that we create without worrying about having any kind of front end. So you can think of this as Postman. So if we work with REST APIs, in order to test our REST APIs, we need to have some front end, because REST API, that's backend, that the job of it is to send some data over some request, to send a response for a specific request. But if you don't have any front end, how are you gonna make those requests? How are you going to test if your backend behaves the way you want it, the way you have written the code for? So you use some sort of a software like Postman that is going to substitute your front end, and it's going to make it easier for you to test your REST APIs in its full capabilities. Now, this is, you could think of this as almost the same thing, but this is for GraphQL API. So we can test our queries in here. We can see what kind of data we get. We can see what kind of errors we get if we do not query for correct data. So everything is right here. I'm just going to go over the interface of this very quickly, and it's actually very easy to understand here on, let me just go like this. So this is the first panel that I want to talk about. On the top, you can see it says documentation. Inside of the documentation, what you have is you have all of your queries that you have written, all of your queries and your mutations. They're going to be here. So we just have one, as I said before, it is hello, and the type of that is string. That is a query that we have written. So if I click on this, it's just going to give you some more information about its type. Okay, let me just go to the Explorer. There we go. So we just have one query, and that is within the root of our GraphQL. And on the top, there are some other options. We can take a look at our collections. This history is actually a very useful one, because if you're working with your GraphQL API for like an hour or two, and you want to go back to the first query you have written or the 30th query you have written, all of them are going to be in here, especially if your queries get longer and longer and you don't want to type it out. This is a very cool way to find out your history of queries. This is, you can search for your queries and mutations, and you can also take a look at these settings. On the top here, we have our local host, which is 3030. And in this second panel right here, this is where we actually write our queries. So what do I mean by actually writing the query? I'm going to come back to this in just 1 second. So this is where we write our query, and this is the response that we get. So where we write our query, that is our front end. So you can think of this yellow box as your React application or your Next.js application. This is that. And this response that you get, this comes from the backend. All right. So you make a query from your front end to the backend, and you get a response based on the query you have done. All right. And now let's go ahead and let's actually make a query in order to understand how all of this comes together. So this is too crowded, the screen. So I'm just going to click on this, collapse. It's going to collapse the documentation. If we need it, we're going to take a look at it. And let's see how we are going to query for our hello. So we know that the type of it is query. We can take a look at that here. If I go to schema, you can see it says type query. So that should be the first thing that I write, right? So I'm going to get rid of this. I could zoom this in a little bit more. I'm going to write query. So query. And what is it that I'm querying for? So we need to open up the object syntax. That's basically the entire foundation of GraphQL. It's just based on objects. All right, so what it is that I want to query, I just have one query, which is hello. So let's just write it. I'm going to say hello, and there we go. And if I hover on it, you can see it already says it has a type of string. Now, we could click on this run, or we could say Control Enter, and that is going to run it as well. And there we go. So what did we do? We said query. That means I'm looking for data. All right, whenever you say query, and especially in programming and backend, that is, you look for data. That's querying. So I'm looking for data. Okay, what kind of data it is that I'm looking for? Well, I don't know what kind it is, but I know the name of that is hello. So this hello, you can think of this as a container or a package that holds our data. So you need to specify what package you need, what kind of a container you need, or variable. So this contains our data, and I'm querying for this. So what I'm basically saying here is, I'm looking for some data that is contained within something that is called hello. I don't know what that is. So let's see what that is. And there we go. We get that. So what we get is an object that looks like JSON, because it is JSON, right? Because whenever we send a response, the most common format is JSON, right? So that is JSON. It has one key that says data, but then what do we have within the data? We have this thing that we queried for. We queried for hello, right? So what does hello contain? It contains this data. So that's the entire premise of GraphQL. And if you understood this, you have basically understood most of GraphQL. You query for some data, you get that data, you show it in your front-end applications. It's exactly the same as REST API. But what is the difference is REST API is much more inefficient than GraphQL. You get exactly what you are asking for. But that's not when it comes to REST API. You don't have that level of control when it comes to REST API. But you do have that with GraphQL. All right? And this is how we go about it. So this is usually all of the queries that you're going to write in GraphQL, a little bit more complicated or a little bit simpler. But then you have something else that is a mutation, that you change some data on the backend. That change could be an update, a delete, a post, whatever. As long as you do some change, that is a mutation. That's what the word literally means, to change, to either, it could be upgrade or downgrade, as long as it changes its current state. That's all right. So we're going to talk about mutations in this video as well. So this is the very first example of how GraphQL works. And we're going to use this Apollo server in order to test all of our queries. All right. And I'm going to close these two other pages. You can go to these pages. That's not necessary for us to actually have open. And now what I want to do is I want to expand on our schema and come back to whatever it is that I want to talk about in this video. So in this video, I'm talking about some sort of a GraphQL backend API that is going to basically be able to handle adding stories, deleting stories, and updating story information, and basically persisting all of that to some sort of a database. Now, keep in mind, we're not going to talk about any front end, whether that's React or Next. The front end is going to be our Apollo Sandbox, but we just talk about the API and the functionalities that this GraphQL API is going to be able to handle, or is going to be able to have, basically. So what it is that I want to do here, I want to create a custom type definition, which is called story. So I'm going to get rid of this. We don't need this any longer. So I'm just going to get rid of this, and I'm going to say I want to create a custom type definition, and it is going to look almost like what they did in the GraphQL website. So I'm going to say type. What is the name of this custom type? I'm going to call this story, but keep in mind that the first letter has to be capital. So the type of this is story. This is going to look like an object. All right. The first field that I'm going to create in here, or basically the first member that this story is going to have, is going to be an ID. ID is going to have a type of ID. There we go. That's the first one. The second one is going to be name. So for every story, I need an ID to distinguish stories from one another. That's one thing. The second thing is I need a name for every story, so I know what story is about, right? What is the type of name? Of course, it is of type string. Next up, I need some sort of a description for that story, what the story is about, what it contains, how the story goes forward. And that's going to be inside of the description, but nonetheless, this is going to be of type string as well. I want to have the ability for users to vote or unvote a specific story. So I'm going to create something that's called voted status, and this is going to have a type of Boolean. I just want to show you that you can use strings, Booleans, type ID. So this is our custom type definition, but this is not going to allow us to query data. In order to query data, we need to have this type query. Remember, we need to have this in order to load data. Basically the get HTTP method equivalent in GraphQL. So if I want to query for story, what should be the name of that query? Well, the name of the query is story. So this story that I've written here with the small s, this is exactly like our hello. So I'm going to go to Apollo Server. I'm going to say query story. But I need to specify a type for this, right? That is something that comes after the colon. What is the type of this? Well, we already specified it up above. So I'm just going to copy that and I'm going to put it here. So I need to explain this once more just to not have any kind of confusion. This story with the small s, this is the data that contains, basically this is the container for our data, right? This is that hello. This is that box in which we want to basically find something. And then the box or the container should have some specific type. For hello, it was type string, but this story has a type of an object. And what does the object contain? It contains an ID, a name, a description, and a voted status. And that's it. So this is how we actually move forward with our GraphQL API. Now, what I'm going to do is next is, if you remember correctly, once we did the type hello, the query hello, we had some sort of a resolver in order to resolve that query for us. So a query on its own provides just a blueprint for our data. It doesn't do anything more, it doesn't do anything less. It is just a structure of how our data is going to look like. It doesn't calculate any logic. So if I want to calculate some sort of a logic, if I want to calculate something, I need a function. And that's our resolver, right? Now we need to jump into our resolvers and update a resolver that is going to be able to handle this specific query. So what is the query? The query is for story that is going to load an object that contains 4 properties. So I need to have my resolver set up in a way that is able to actually do this. So let's go step by step. We are within the query. Why it is a query? It is because we just want to load some data. We don't want to change anything. So that's a query. It's not a mutation. So what is the name of the query? Well, we specified it as story, right? So I'm just going to copy it, story with a small s, all right? There we go. And then we know that this query should be a function because it needs to calculate some stuff for us, all right? That's a function. So here it is a function, so I'm going to get rid of that. I'm going to open up our function body. And inside of here, I'm just going to open up our curly braces because what this function produces is going to be an object. So shouldn't we open up curly braces? So what is the first thing that this story object produced by this function is going to contain? Let's take a look at that. Well, that's an ID. All right, let me write ID. All right, so I've written the ID. What should I write for the value of this key? Now this object, it needs a key and then it needs a value for that key. Well, I'm just going to keep it simple. I'm going to say, okay, it is 1. Then what is the second property? It is called name, right? So what should be the name? I'm just going to copy paste something into this file, into here. And we're going to take a look at that. So I have created this file. This is stories.js. Inside of this file, you're going to find 20 different stories with different properties. So stories, they have an ID, they have a name, they have a description, which is right here, and then we have a voted status. Now, there are a couple of more things that we have not talked about. We have an array, and then we have a number. As I said, we're going to incrementally update our custom type that we created inside of the schema. We're going to update that. But for now, we just talk about the first 4 ones. So the ID is 1. The name is going to be this. So let me just copy paste it here. That's the name. I need a comma in there as well. After the name, I have a description. Let me put the stories on the left. So there we go. This is a description. I just don't want to do lorem ipsum. I just want to keep some things interesting, so it is not boring to take a look at this. And the voted status for this specific story is going to be set to true. So this is what our resolver is going to do. It is going to generate a story with all of this information. And that should be it. Let's just save this. And there we go. You can see our error is gone. And now let's just jump into the GraphQL Playground or Apollo Server Sandbox. So before moving forward and writing this, what we need to do is we need to actually make sure that we take a look at our documentation to find out if all of this has been accounted for. So if I come to the documentation, now you can see instead of hello, I have this thing which is called the story. Now keep in mind, this thing on the left of the colon, that's the container. On the right of this colon, this is the type of that container, right? That holder of data, right? That keeper of data. This is the keeper of the data, and this is the type of that. And so now that you know that, let's go ahead and let's click on this. So here we go. And now once I click on it, we're going to see all the consisting members of this specific holder of data, which is called story. So what does it contain? It has description, ID, name, and voted status. So we have all these options. We have all of their types right in front of them. So let's go ahead and let's write the query for it. Now keep in mind, this is still a query because that's what we specified inside of our schema. And now what it is that I want to query for. What is the name of the holder of data? Well, that's story, right? That's a story. So after that, I need to specify what I want from this holder of data. So this holder of data, it contains an object, and then the object has 4 properties. Maybe I just want to have the ID as well as the name, and that's it. So I could say run, and there we go. So again, what we do here, this is like our front end. We make a call to our backend. And what we get here, this is the data that we get from the backend, and we send it to the front end. So in essence, this is the API call to the backend. This is the data that we show on the front end, that we show inside of the browser so users can see them. That's why it's in the JSON format. It's easily convertible to a JavaScript object, and then you can iterate over it. You can get the data, and that's easy. You know, you have all of that experience. So we queried for, so this is a query that means get data from this holder of data, which is story, and the story gave us ID and name. And let's take a look at that. So we have our ID story, data, and data is called story. Story gave us ID and it gave us name. So ID is 1 and the name is this, Quantum Dragons Paradox. Now, of course, we just get the data that we asked for. We don't get description. That's the good thing with GraphQL. Now I can say, give me description, but don't give me the voted status. I don't want to know if anyone has voted for this. And there we go. We got that. We could get rid of the ID, or you know what? I'm just going to keep the ID, but I'm going to also go to voted status. Let's run it, and there we go. Voted status is true. And you can see it's not being surrounded by quotes because this is a Boolean value. Let me put it there. And you can just remove any of these you want and keep any of these you want. So that is the second query that we have made. And I'm sure by this point in time, it's everything when it comes to querying has become very, very clear for you. So what we need to do is, what I'm going to do next is I'm going to talk about a couple of different types of data, more types of data that GraphQL gives us, and then we're going to jump into mutations. And what I'm going to get started with is going to be an object. So let's jump into our VS Code, and I'm going to jump into schema. So what we have done so far is we created a custom type definition, and we called it story. And then we said how we can basically query for that story, and we could define or select whatever data we wanted from that story. Now, what if you want to add something else in here? What if you want to add an array? How are you going to go about that? And what I mean by this is, let's say we have these stories, and for every story, we want to add more information. We want to add a theme of the story and a genre for that story. Even though this is going to be one object containing 2 different properties or 2 different items, that is going to be surrounded by an array, because We might end up adding more items to this. We might have some other data. So I'm just going to represent an array, and inside of it, I want to add an object. So how am I going to go about this? What we're going to do is you need to know that you could call the name of the key whatever you want. So this could be whatever you can think of. I'm going to just say metadata. And this is going to be an array. So that's the first type. But within the array, what it is that we want to define? Well, we want to define an object shape. Now, I'm going to add an exclamation mark outside of the array. And that is basically going to mean that it should not be null. This exclamation mark basically means that this is a required field. So it doesn't matter if whenever you query, if you provide the ID, the name, description, or voter status, you need to specify the metadata. What is metadata? Metadata is an array that is going to contain a custom type definition called meta. So what is this meta? Let's go ahead and let's create it. So I'm going to come right down here and I'm going to say type meta. And then we said, okay, this is going to contain a theme. What is the type of that? It's going to be a string. It's also going to contain a genre, the type of which is also going to be a string. So this is our new type definition. And what we need to do next is we need to make sure that our resolver can actually handle this new type definition. So I'm going to save this. Let's jump into our index. And in here, I am going to jump below there and I'm going to say metadata. This is going to be an array, but then within that, we just have an object that is going to have a theme. Let's say it is dragons, and genre. That's going to be science fantasy. There we go. So now let's jump into our Apollo server, and we could take a look at how this has changed through the documentation. So if I come right here, now you can see we have this metadata that we can also query for. But if I click on it, it just has two things. So I need to specify at least one of these in order for our query to actually make sense. So in here, I'm gonna just say, let's just say I just want to grab the name. And I'm just going to write metadata. Let's add, so we could add a theme and also a genre. Let's run this, and there we go. So the name of the story, now where is this story coming from? For now, this is being fed to our story query, and it is very hard-coded. You can see we just hard-coded this, and you can't actually add this. So there are no mutations. We're going to add database persistence, and through that, we're going to add the ability to change a story, to create a new story, and all of that. But for now, we just want to make sure that we can query different data, and you can get started with this and really understand how these work. So let's say I want to grab the story name, but then I just want to have the theme of the story. I can do that as well. Or I just want to have the genre for the story. And there we go. So you can see this is the data that we get. It is very, very specific, and that's exactly what we want. So from this point onwards, so let's go ahead and let's talk about mutations. What are mutations? Well, technically, mutations are GraphQL operations that allow us to modify data. And what do I mean by that? They allow us to create or update or delete data. Well, the difference between a query and a mutation is that with queries, we just read data. So it's like GET requests, but with mutations, we can write or modify data like POST request, a PUT request, a DELETE request. So that's the difference between these two. So let's jump in. Let's actually take a look at how we can add a mutation to our current type definitions. And one thing that you need to keep in mind is that we cannot use the regular type objects as arguments. We need to use something that's called an input type. That's something that we're going to use with our mutations. So let's go ahead and let's jump into our schema. I'm going to go down here. Now, what it is that I'm actually trying to create. So I want to create a mutation or GraphQL operation or a function that is going to be able to create a new story for me. And the story should have all of the information that is included whenever we query that story as well. So the story that we want to create, it should resemble this story, right? And the metadata that we want to create, that should resemble this metadata. So for just better readability purposes, I'm just going to put these here. There we go. So we basically say, okay, this is for querying data, but then we need to create something similar in order for our mutations. But our mutations, they're going to be using not the type keyword, but they're going to use the input keyword. So here I'm going to say story, but since this is a mutation, that means with this input, I'm going to be able to create a whole new story. So I'm going to just call this story input. This means I'm inputting a story. But what are going to be the consisting properties? It's exactly these ones. Why? Because with mutations, you create new stories, but with queries, you display those newly created stories. So their members, they have to align. If there is something that I add here inside of my mutation that is not within my query, then my query is not going to be compatible with the mutation. Because mutations and queries, they go hand in hand. Queries display what mutations have created, all right? Now, so far, it's not the case. That's because we have hard-coded all of the data here, but later on, that will be the case, all right? So we need to get started with that. So all of this comes right here, but then we need to specify this. You can see this metadata right here. It is being mapped to this metadata that we have here. And that is not a mutation. This is actually a query. So what we need to do is we need to convert this into a mutation as well. So this is going to be input I could call it meta input, right? So this is meta for the query. For the input, I'm just going to call it meta input. There we go. So what does it contain? Again, the same things. We create and display the same kind of data. There we go. So far, we have created our mutation. And now we need to also make sure that we have something in our resolvers that is going to be able to handle this mutation for us. So I'm going to jump into our index.js file. And in here, let's go to the top. I'm going to go above our resolver. And in here, I'm going to create a function, the name of which is going to be create story. So this function is going to receive a parameter that's going to be called ID, but then this ID is going to be for one specific story. And what properties is this story going to contain? Well, we know that, right? Every story contains an ID. Well, we have already written that, so I'm just going to remove it. Every story contains a name. It contains a description. It contains a voted status as well as metadata. There we go. And what does this function return? It just returns an object. And we are going to say ID is going to be equal to ID. But whenever in a JavaScript object, the key and the value are the same thing, you can just shorten it and you're going to say, you can just write one of them and it's going to convey the point. All right. So ID is going to be equal to ID. Name is going to be equal to name. Description is going to be equal to description. Voted status equal to voted status, and metadata equal to metadata. And I need to add a comma there. So this is our create story. And let's go ahead and let's add this mutation. So far in our current implementation, we don't have any mutation within our resolver. So you can see the resolver contains one thing. And what is that thing called? It's called a query. We know that queries and mutations are different, right? Queries display data, mutations change data. So let's go ahead and let's actually create a mutation. So outside of this purple curly brace, which is where, on this line 38, which is where this query ends, I'm going to write something that is called a mutation. So this is how you need to actually write a mutation whenever you're working with Apollo Server. You need to specify that this is a mutation, and you need to specify that this is a query, all right? So what do we do with our mutation? Well, we have created this function that is called create story. And the first argument of this function is the ID, which I'm going to leave behind. I don't need that. The second part of this function is the input. So what do I want to do with the input? Well, you need to understand what the input is. Well, what is the second parameter that this function accepts? Let's take a look at it. It is name, description, voter status, and metadata. What is that? That is one individual story. All right. So this input is actually one individual story. But what happened to the ID? Well, we don't want to hard code IDs. We don't want to say, okay, 1, and then I should write 2, and then 3. And then if there are like 150 different stories, I need to like count or like increment that manually. That's going to be very exhausting. So what we can do is we can create IDs on the spot, and we can make it as unique as possible. So we have this crypto.randomUUID, universal unique identifier, that is going to do exactly what we want. So this is going to be our ID. And what this is going to do is it's going to create a sequence of alphanumeric characters, but every time for every story, that sequence is going to be different. And we want to set the ID of our story with that. So before moving forward, we need to have an in-memory database in order to store the newly created stories. And that in-memory database is going to be const right here. This is going to be stories DB, right? And this is going to be an object because all of our stories are objects. I'm just going to put all of them right here. So this is our in-memory database. There we go. And let's just add individual stories to this. So I'm going to say stories DB. And at any specific ID, I'm just going to put an input, which is going to be that story. This is mistyped. There we go. And finally, what do we want to return? We return create story. Let's pass in the ID and we pass in the input. There we go. So let's save this one as well. There is still an error, and I'm going to explain why we have this error. But before moving forward and explaining that, I need to explain this part. I think I need to explain it a little bit better. So we have here a create story. This create story. So this create story is different than this one. This create story is actually a mutation. Yes, both of them are functions, but they serve different purposes, right? They're named similarly, and let me just think for a few seconds. So if I could come up with a different name, create story, created story, or create story mutation. I could call this create story mutation, mutation, right? So now you know that these are different. So this is a mutation, and this is the function that we created above that is going to return a story for us. All right, so we have an ID as the first parameter, which we leave behind because we generated right here on line 44. And then we have an input, and every input is going to be, since we are within mutations, every input is actually an object that is going to be one individual story. And we create a database in order to put those individual stories at their correct identifier place. And then we call our create story with these information. So we pass in the ID. That's the first argument of the create story. And we pass in the actual story, which is the second argument. Now, there is still an error, and the reason for that is because we have not actually defined our mutations. So what we have defined here is the structure of the data, but this mutation that you write here, this function, it has to be defined here as well. So let's go ahead and let's actually define that. And for that, it's actually very simple. You're going to say type mutation. You need to specify this. As with type query, you specify that, okay, I have a story that I want to query, all right? So the query name is story, but then what is the name of your mutation? What did we name that? We said create story mut. So this mutation is a function. What is this going to accept? Well, this is going to accept an input. The type of this is going to be story input, but what is this function going to return? It is going to return a story as well. And let's just go up. Let me just save this. And there we go. You can see all of the errors are gone. So now if I go to our browser in order to test this, it's going to make a lot of sense, right? So I'm just going to delete everything. Let's go to our documentation first. Let's go to root. So if I go to root, now you can see I have one query, which we talked extensively about, and then I have one mutation. Within the mutation, I have this create story mut that I need to use. So this name is very important. And then that's going to generate basically these things for me if I pass them there, right? So let's go ahead and let's see how we use this. Well, for query, we said query. For mutation, we're going to say mutation, right? What is a mutation? It is a GraphQL operation that changes data. And in here, what is the name of this mutation? It is create story mut. So what is this going to accept? Let me just delete these curly braces first. This is going to accept an input, and the input is going to be the following thing. So input is going to have a name. Let's say new story. I'm just going to say new story. And then it's going to have a description, a tail, whatever. I just want to make this work. Voted status, let's set it to true. And then metadata, that is going to be equal to, what am I going to pass in here? Let's just specify this better. So metadata, this is going to be an array that is going to contain an object. The object is going to contain theme, which let's say add adventure, right? And then let's add the genre as well, which is going to be fantasy. There we go. And okay, so this is the mutation that we have written. And this mutation is going to create a new story. And it is going to give it a name, which is going to be new story, description, a tail, voted status true. And then it is also going to give it the following metadata. But then let's go ahead and let's query for this data so we can actually see that as well. And in here, I'm going to say, okay, give me the ID, give me the name, give me the description, give me the voted status, and give me the metadata. That is going to be theme. Let me just hit enter, theme and genre. So let's go ahead and let's run it. And if it were to fail, you're going to see some sort of an error here. But since it just went on and it was successful, we see the following data. So we said that we created a story using this mutation. It is called create story mut. The story has a specific ID, and this ID comes from crypto.uuid, random UUID. And you can see it's extremely long and it is extremely random. This is the name, this is the description, the voted status, as well as our metadata. Now, if we were to change any part of this, let's say I don't want to take a look at the voted status, and I don't want to know what the genre is, perhaps the theme of that. And if I change it, you can see the data that we receive changes. So the good thing with GraphQL is you can pinpoint exactly what you want. You can be very specific. You can be very pedantic in a positive way, right? And you can specify, okay, I want this and just give me this, and I want to create this. All right, and I hope all of this has been clear so far. I tried to explain it in the simplest ways, in the simplest manner possible. So let's go ahead and let's move on and let's see how we can actually try to organize our code a little bit better. And the first thing that I'm going to do is actually extract our resolvers from here and put them in their exact specific file. So where do you think we should put our resolvers in? Well, at the start of this video, I said something about this data folder, that this data folder is going to contain our schema. It's going to contain also our resolvers. So let's go ahead. Let's right click in here. I'm going to create a folder. I'm going to call it resolvers.js. There we go. And I'm going to put it right after the schema. Let's jump into our index. So which part is our resolvers? It starts from this function. So I'm going to select all of this. I'm going to select our in-memory database, and I'm going to select this part all the way to our server. Why do we do this? Because this part, this resolver part, this is a different logic than our server setup, right? So we need to basically make sure that we separate each component or each part of our application in its own specific file, so it is more manageable and more readable. So I'm going to cut all of that. You can see our server config has just become so little. So let's just put everything right here. So with our current implementation, what we do is we query for a story, and at the same time we create that story. Well, what we could do is we could actually change this resolver a little bit as well. So we could say, instead of querying for a story and creating it at the same time, let's just make sure that we don't have this hard-coded story. So what I'm going to do is I'm going to refactor this a little bit, and there is some repetitive code as well. We have an ID here, and then we have an ID here. We have a name here, and then we have a predefined name, which doesn't really make sense. Yes, for testing purposes, but now that we have a little bit experience of GraphQL queries, it doesn't make sense anymore to have all of this here. So I am going to get rid of all of this story thing, and I'm going to say get story. This is going to be a function nonetheless, but this is going to be a function to get some query, to get a query working, or basically to load data. So what it is that we want to load? Well, let's take a look at our function up above. So this function creates story. It accepts two parameters. One is ID, the other one is something that looks like a story, and it is a story, right? So we could leverage this create story function for our query as well. So we use that for our mutation. You can see we have create story, and then we can use the same create story for querying as well. That's better, right? So how do we do this? Well, we need to have the first parameter of the function, which is the ID. And I'm going to denote it as an underscore because I don't need it. But in the second part, which is the actual story itself, we still have an ID, right? And what is this query actually about? The query is about loading or getting a specific story. Well, how do you get a specific story? You could load it up by its name, but then two stories could have the same name. You could load it up by its description, but then that query is going to be too long, right? It's going to be too long, so it's several paragraphs. You could load it up by its voted status, but then that could be problematic as well, because some stories, like 10 stories, could have a voted status of true. And then, like, what about metadata? Some metadata could be shared across several stories. So you need to take a look at what is unique, specific to any story. That's the story ID. And that's exactly what we are going to destructure from any individual story. So the way users can get the data for any story is the only way they can do that is to provide the ID for any specific story. So the ID is unique for any individual story. If you provide it, you're going to get the rest of the data. Otherwise, you're not going to get anything. So what we do is we say, okay, as soon as user provides the ID, we're going to invoke this function, create story. We're going to pass in the ID that the user has given us. And depending on this ID, we are going to take a look at our database. And we are going to sift through our database based on this ID. That's it. There we go. So we say get story is a query. As you can see, it's written inside of the query. User is going to pass in an ID, And once we receive that, we invoke this create story function, this function, with this ID, right? And then we say, okay, this now create story as a second argument needs to have a story object. And we already know that the story object is stored within the stories DB. So we sift through our DB based on that ID that the user has passed. And we show the story that the user is specifically looking for. All right. So this is how we actually can modify our queries so they work with a broader basically input of data, or broader queries that users are going to basically look for. Now, what we need to do next is we need to also basically set this up inside of our schema, because we don't have this get story. So let's go ahead and set this up. So here I'm gonna say type query. Well, we already have type query, so I could just write it beneath there. And this is called get story. What this is going to accept is an ID, type of ID. What this produces is going to be a story object. There we go. Now, since it was a query, I just added it here. I don't have to do anything else. Now, we need to import our resolvers before saving this from our from our resolvers file. So here I'm going to say import resolvers from this should be within curly braces, resolvers from let's go to data folder, and from there we're going to select resolvers.js. Okay, there is a typo, import. Let's save this, and resolvers. Is this correct? I think it's correct. Let's see what the error is about. So it says does not provide a named export resolvers. Yes, it doesn't provide it. It basically says that we have created our resolvers, but we have not actually exported them. So we need to go ahead and export our resolvers as well. So on the bottom, I'm going to say export default resolvers. Let's save this. There we go. Everything is working perfectly fine. Now, what did we actually change? We got rid of that story that we created, right? That a dragon's paradox, something, right? And now, if user wants to take a look at any story, user has to create that story first. So let's go ahead and let's actually test this in the browser and see what we get. So now if I go to my documentation, go to root, now we have one mutation and then we have one query. If I go to query, we have this story query where that's going to give us the story. Where is the other one? We should have two queries here. Let me just reload this page. A site can't be reached. Do we have an error in here that we have not fixed? Okay, it says, oh, I fixed that, didn't I? Export default resolvers, and inside of the index, we said data resolvers.js, didn't we? Or is the name resolvers? Everything seems to be okay. So let me just close server and run it again. We still get the same problem. So resolvers, const resolvers, export default result. Everything seems to be okay. And let's come right here. I think I need to get rid of these curly braces, because that is the default export, and there we go. It is working. Let's reload the page. Sorry for the flash. And there we go. We got our get story. So it was just a syntactical error. So let's close the documentation and let's actually try to test this. So if I want to see a story and I don't have any story, I need to create it first, right? So let's go ahead and let's say mutation, but then let's see if this history actually works. So this is the good thing about history. Here we have our mutation from before, right? So let me click on it, close this, there we go. So inside of this mutation, we created a new story. We called it a tail. Voted status is true. This is the metadata, and we got all of this information. So let's run this. There we go. So I'm going to get this ID, right? Get this ID, just copy it. So now let's see. So our mutation works perfectly fine. All right, we created a story. And now let's see if we can query this story as well. We can load this story up as well after we have created it. So for this one, what is the function that we created? We said, okay, it is called get story. It is going to contain an input. The input, it's going to contain an ID. The ID is going to be this. This is the story that I'm looking for. And can I just move it so you can see the syntax better? There we go. And what is it that I want to get from this story? Let's get everything. So ID, name, description, voted status, metadata, which is going to be genre, theme, and genre. Oh, whoops, not saving this. Let's just run it, and there we go. So we created a story using a mutation, and then we queried that story. And it's the same thing. You can see the ID is the same. So if you create a new story, you can query that story as well. But the problem with this method, with this approach, is that if we refresh our server, or our server is caught up in any way, we don't have any data persistence. So all of the stories that we create, they're going to go away. What I'm going to do next is just create another story as well. Let's take a look at this. So this is going to be a new story 2, a tale of tails. Voted status for this one is going to be false. The theme is going to be the same thing, the theme and the genre. So let's run it, and there we go. So we got a different ID. And now I'm going to copy this. Let's do our query. Now you can see this history is very, very good, right? And if I paste it and run this, and there we go, we got the second story. So now we have access to do two different stories. Let me bring this down a little bit. So what next? Let's go ahead and let's talk about one more type, and that is going to be the number type. So I can add this age rating, and after that, we're going to add our data persistence, or our MongoDB. So what is this number type? Well, a number type is basically a scalar type. A scalar type could be an integer type, which is a signed 32-bit integer. It could be a float type. It could be a string. So some of the scalar types we have already talked about. So if I come right here and let's go up. So this this string, this is a scalar type. Boolean is also a scalar type. ID is also a scalar type. And now we talk about another one, which is an age rating. And now that I'm here, let's go ahead and add it. So that is going to be an age rating. And this is just an excuse for me to introduce you to the int type, which is another scalar type. So this is going to be an integer. Keep that in mind. This is not going to be a float. So it's going to be like 8, 10, 12, 15, 16, whatever the age rating for any of the stories is. All right. It doesn't make sense for any of these stories, just to be clear, to have an age rating. It's like some made up stories, but I just wanted to introduce you to this integer type. And I couldn't think of anything better than age rating. All right. So now that we have age rating here, this is our query, but as you saw just a couple of minutes ago, we need to have our mutation first. That is going to create our story, and then we are going to query for that story. So the type of data that we have for this story object, for our query and our mutation, they should align. And what do I mean by they should align? Well, our story currently has 6 different members. So 1, 2, 3, 4, 5, 6, right? But our mutation, it only contains 5. Let's add the 6th one as well. So age rating, type of this is going to be an integer as well. Now, we need to save this, jump into our resolver, and actually update our create story function with this as well. This is going to be age rating. And this is very easy for you as you're seeing this. If you want to add more data to your current whatever object that is. For me, it's a story object. For you, it could be any object, any project that you're working on or you want to get started with. So we have this age rating, and after that, we can just jump in and test it in the browser. Very simple, right? So save this, jump here, and let's go to our mutation. And this is our mutation. So I could call this new story 3, a tale of tales hyphen v2. And yeah, let's let the metadata be the same thing. I have age rating. Let's say this is 18 or whatever. And I want to take a look at the age rating here as well. Give me the genre. Okay, what do I have here? Oh, I already created that, but then I want to have the voted status as well as the, I have the metadata down below. So I'm going to cut this age rating, put it here. Let's remove the space. Let me create another one, and there we go. So this is a tale of tales v2, and here is our age rating. So if I were to query for the story, we created actually 2 stories, but I'm going to query for one of them. So I want to find a story whose ID is this, right? So this is what the query is saying. Give me a story, the ID of which is this right here. So this is the ID. And once you got the story, from that story, I don't want to see all of the information. I just want to see the ID, the name, the description, the voted status, the metadata, or let's just change some stuff. So since I already know what the ID is, I'm going to get rid of the ID. I want to take a look at the name. I want to get rid of the description and get rid of the voted status. And I just want to say take a look at the age rating. So you can see I'm being very specific in what it is that I want from this story whose ID is this long thing. Long sequence of alphanumeric characters. And as soon as I run this, there we go. So the name of this is new story 3. This is the metadata, and this is the age rating, right? This is very cool. So now that we have talked about another scalar type, which is integer, I think it is time for us to actually get started with our MongoDB setup. So I'm going to use MongoDB because it's very, very seamless if you want to work with MongoDB with this GraphQL API. And that's going to be it. So in order to work with MongoDB, there is some setup that's going to be involved, and you need to do that on your own, all right? And I'm going to give you 2 links. So I'm just going to go ahead and paste them. I could paste it here, or I could paste it in code inside of, where should I put these? So below this index.js, I'm going to create a comment and I'm going to say install MongoDB. If you don't have it installed from this link, so if you just get the repo from GitHub, you're going to see this link, or you can just Google download MongoDB Community Edition. That's it. And then this is going to help you download the installer for MongoDB. It's a very smooth process. You can install it as well. But if you want to have a step-by-step video guide, I have already mentioned this video several times whenever I teach MongoDB installation. I believe this YouTube video is one of the best installation guides for MongoDB. It's very, very thorough. So if you just take a look at this, just copy paste it into your browser, you're going to see this. It is by this programming knowledge channel. It says how to install MongoDB 6 on Windows 10 and 11. It is going to work for for the current version of MongoDB as well. So it is 13 minutes. It's pretty thorough, and it's going to tell you everything you need to know when installing MongoDB. All right, so these 2 links, I'm just going to leave them here. Save this. You can get this from, of course, the repo is on GitHub. You can get it. You can just go ahead and get it from there. So next up, I'm going to close the server. There is actually a package that we need to go ahead and install. And that package is called Mongoose. Mongoose is basically a tool for using MongoDB with Node.js. So if you want to use MongoDB, Mongoose is going to help us to create a schema, to define how our data from MongoDB is going to look like. It's going to help us to easily save some data to MongoDB, find some data from our database. We can update some data on the database. So all of these very useful things that we want to do with our data, Mongoose is going to help us accomplish that better. So the way we can install Mongoose is npm I mongoose. Just hit enter. That's going to install it for you. You can take a look at your package.json. It's going to come right here momentarily. It's going to take a few seconds and it's going to come there. And there we go. Mongoose has been installed successfully. There we go right there. Now, I am going to open up MongoDB Compass. This is the software that I told you that you need to install in order to work with MongoDB. Let's just zoom this in. So whenever you install it and everything goes smoothly, you're going to see something like this. This is going to be localhost 27017. That is the default port on which our server for database is going to run. So what you're going to do, the only thing you need to do is you're going to hit this connect button, and this connect button is going to help you connect to your database. So whenever everything is successful, you're going to see something like this, like admin, config, and local. All right. Now, these are the database that are already existing here. We're going to create a new one using Mongoose. So let's jump into our code. And before actually, you know what, I could say, let's keep the server running, npm start. And let's bring this down. Now, once if we want to basically connect to our database, there is going to be some logic involved in that. So we need to do some sort of configuration. And the best way to do this configuration is to actually create a separate file for it. So for that reason, I'm going to click on this data folder, and inside of there, I'm going to write something like db connectors or db connector, since we just have one database that we want to connect to. And there we go. So let me put it on the end. So what do I want to do here? Well, this is just going to contain the logic in order for us to make this connection to our database. So how do we go about this? The first thing that we need to do is we need to say import Mongoose from Mongoose, because we use this package to connect to our database. Since connection to a database is going to take a few seconds or some time, this should be non-blocking. It should not block the flow of our app. That's why we are going to say, okay, this is an async function. And you can call this function whatever you want. I'm just going to call it connect to DB, right? Very specific name. So how do we connect to our DB? Well, we first need to await our Mongoose. Mongoose, and we need to specify at which specific address we want to connect. Well, we already know what that is, right? So connect, let's get mongoose.connect. Let's provide the address. The address is going to be MongoDB, and then : // Remember, it is localhost, but then you need to specify what database it is that you want to connect to. Well, we can connect to any of these existing databases like admin, config, and local, or we can create a new database and connect to that one. So I'm just going to create a new database, and I'm going to connect to that one. And I'm going to call that stories-GraphQL. That's going to be our new database. And if this connection was successful, I'm going to log something to the console. I'm going to say db connection successful. So many doubles. So successful. I think there is just one L, right? In there. So this is our function connect to DB. And then we need to call this function or invoke this so it can get up and actually start working. Now, what else do we want to do? Well, we need to specify how our schema is going to look like, because this schema is going to travel to our database, right? That's what's the schema that we defined in GraphQL. That's the schema of the data that we want to get. But then we need to have a different schema that we can send to our database. So this one, I'm going to call const story. I could call it story schema. And we already know how the schema looks like, but we don't know what function we need to use in order to create that. We can say new mongoose, lowercase, mongoose dot schema. And then our schema is an object, right? We have a name. Why don't we provide this string? Why don't we provide the ID? Because that is something that MongoDB provides on its own. So we don't have to provide it. We have this name. We have the description, I hope I don't make a mistake, a typo here. And then after that, we have the voted status. This is going to be Boolean. There we go. After that, we have the metadata, which is the type of which is an array. And finally, we have this age rating, the type of which is a number. There we go. So this is our schema. Let's go ahead and let's create a collection for our database. Now, databases in MongoDB, they require some sort of a structure in order to store our data. So the structure that we use, they are JSON in MongoDB, so they're called documents. But then documents, they need like a bigger folder that we can put documents in. And that folder is called a collection. So any database could have one collection or more collections, right? One or more collections. But since this is a very, very simple app, this is a very simple example of how GraphQL works, we want to keep everything simple. So I'm going to create a variable and I'm going to call it stories. And we're going to export the stories as well. And we're going to say mongoose.model. And now you can see how this mongoose is very important. It's like the middleman between our server, our GraphQL server, Apollo server, and our MongoDB, right? So we say model. What should be the name of this? I could just call it story, but then MongoDB is going to change its name from story to stories. It's going to pluralize it for us. And then what is this? What is the schema that we want to pass in here? Well, we already created that up above. And finally, in here, what we want to do is we want to export stories because we're going to need this. Now, here I have the stories.js where we have 20 different stories. And as a starting point, I want to grab all these 20 different stories and I want to put them inside of our MongoDB database. But for this to actually work, we need to change our resolvers a little bit. So here, we no longer need this function create story. So I'm going to get rid of this. I'm going to go ahead and get rid of this in memory database as well. We no longer need that. Let's go ahead and let's import stories. I'm going to import it from dbconnector.js. I just imported stories. And now here, what it is that we want to do? Well, we want to get a story. And so far what we did was we got it from this create story that I just deleted. So let's go ahead and let's redo this. We want to get the story from our database. That means this operation is going to be an async function. So if you want to get something from the database, this is how it's going to go. Whatever we get from the database, we put it inside of this variable, which is called story, right? And then once we actually want to talk to our database, that's going to be an async await operation, right? We get our stories, and on the stories, we have now whatever that I'm about to write here, that is actually a MongoDB query. That is going to be a MongoDB specific method. It has nothing to do with JavaScript, all right? And it is called find by ID. So inside of our query, what we did previously was to find a story by ID. We just changed that, targeted from our in-memory database to our MongoDB database. But we still want to find a story by its ID. So there we go. We just pass in the ID here. And what do we return to the front end? We return that specific story that user wants. So user is going to pass in an ID, and then user wants to see either the entire story or whatever user wants to see specifically, because it is GraphQL, right? Everything is very specific. All right. So this part is actually done. And I'm not going to make any changes to our mutation. I'm just going to leave it as it is. So let's go ahead and let's save this. And there we go. You can see after saving this, we have, since we didn't have any way of actually using this dbconnector.js file, all of this that we have created, all of these the database connection logic or configuration, we didn't have any way to use it. And now since we used it and it was successful, we can see this message here. So you need to have this message, this one right here. It says DB connection successful. So this means if I go to my MongoDB and if I click on these three dots and refresh this, you can see I have my stories GraphQL and these three disks, whatever these are. So this is a database icon. That means we have successfully created a database which is called stories-GraphQL. And as I told you previously, our collection name is story, but GraphQL pluralizes that. I wanted to show you that as well. And this is our collection. So a collection, as it says right here, it is empty. And a collection is basically where we put our data. So you can just go ahead and import a JSON or a CSV file, but I'm going to show you how you can do this the better way. So here on top right corner, and click on this Open MongoDB shell, you're going to see something like this, like that we have switched to this database, stories-GraphQL, and you're going to see this use stories GraphQL. If you don't see this stories GraphQL, you can just write this query. You're going to say use stories GraphQL. I'm going to show you how to do that. So let me get rid of this. You're going to say use, and then you need to specify which database you want to use, right? So I want to use the stories-GraphQL database, hit enter. It is going to say, okay, we are already on this database. So this means that we have already selected that. And there is something that we're going to do. So we're going to say db.stories. Stories is the name of the collection, and we want to insert many stories inside of this collection, because as we saw, the collection is empty. And the method that we're going to use is going to be insert many, right? And this is going to accept an array. Whoops, I shouldn't have hit enter. This is going to accept an array, and inside of this array, you can go ahead and you can put all of the objects, right, from your stories. So I'm just going to go ahead and I'm going to copy paste this entire thing. And if you just wait a second, sometimes if you copy paste it from the stories.js file, you're going to see some errors that maybe a semicolon is missing or a comma is missing. So I'm just going to hit that enter, and there we go. So I was able to successfully create all of these stories. And you can see once you create the stories, MongoDB gives them IDs on its own. So these stories have these specific IDs. And if user wants to select any of these stories, user has to specify the ID of that story. So give me the ID. That's what MongoDB says. And I'm going to give you the story, right? Just give me the ID. Now, I feel like I need to give you this string so you don't end up with a lot of errors. So let me just copy this from my notes. This is the entire thing. And I'm going to go inside of this index.js file, right? And I'm going to paste, where am I going to put it? You know what? I'm going to create db collection insertion.md. This is going to be a markdown file. So here I'm going to do triple backticks JS, put that. I'm going to do triple backticks, and I'm going to save this. All right. This is not going to add any commas. Since this is markdown, it's not going to add any commas. It's not going to do anything. So what you're going to do is you're going to just copy this entire thing, after you have selected that, after you have said, okay, use stories GraphQL, just copy this entire thing and paste it in MongoDB shell, hit enter. It's going to create all of the stories for you automatically. But please do not add these backticks. That's a markdown specific syntax, all right? Just start from line 2 and end at line 169. Do not include line 170. You don't want to go there, right? 169 is perfect. So I'm just going to put it there so you can use it. There we go. Let's save this. And now if I close it, just go ahead and close it. And okay, I just imported 20 stories. Where are they? Well, you need to refresh your database. So I'm going to say refresh, and there we go. We have all of these stories. How many are there? Well, what does it say? It says 1 to 20 of 20. So there are 20 stories. But this page has the ability to show 25 stories, 50 stories, 70 or 100 per page. You can, this is very, very advanced when it comes to the options. You have a ton of options in MongoDB Compass. So just keep that in mind. All right. So as our starting point, we have 20 stories. Can we query this inside of our Apollo server? Yes, we can query them because we have already implemented the query for these. Therefore, we have the ability to query these. Let me jump in here. We don't have any errors. That's a very good thing. So I want to get a story. What is the story ID? Well, I need to specify. Let's say the Dreamweaver's Rebellion. I'm going to select. I'm going to copy this entire thing. Click cancel. Come into my Apollo server. So let's paste that in here. What do I want to get from this story? Everything. I want to get the story ID. I want to get the name. I want to get the description, the voted status, as well as the age rating. Let's run it. And there we go. You can see we got that story. So this basically means our GraphQL has been successfully connected to our MongoDB, and we have successfully persisted all of our 20 stories at this point, and we can select any of the stories that we want. I'm going to do one more just to make sure everything is working correctly. I don't know which one to do. The symbiotic cities of Gaia Prime. We could just double click there, copy it, and come right here and put it right there. Run it. There we go. We get all of the information because we said, okay, I want all of the information. But then you could get rid of any of these and you're still going to get that story. Perhaps you're just interested in the name of the story and some metadata because metadata is required, right? You're just going to run it and there we go. That's the story for which this is the ID, right? So you can see how everything is coming together, and it is really, really cool to see all of these. And now the next step for us would be to actually modify this mutation in order to create a new story. With our current implementation of create story mut mutation, we cannot actually create a new story. So how can we do that? Let's start from the top. I'm going to keep the name as it is, create story mut. This is going to be an async. You can just memorize this whenever you're working with databases. It's async. We still have our input. And now whenever we say create a new story, you know what? I'm just going to get started from scratch. We want to create a new story. So let's create it. New story is going to be stored within this variable. And we're going to select our stories from our database. And what is the data for any individual story? We have the name. This is going to be equal to input.name. We have the description. This is going to be equal to input.description. Now, why am I saying input.name, input.description? The reason for this is because our name for our story comes from the input that user writes. And from that input, we get the name because input is an object. We say input.name, we get the name property of that object. we say the description comes from the description of that input because we're trying to create a new story. So if you want to create a new story, you don't have you should not have the ability to cherry pick properties of the story. You need to specify all of the properties, right? So we can query that, all right? So all of the properties are the name, the description. What is the next one? It is the voted status. And this is going to come from input dot voted status. What else do we have? Let me add comma there, another there. We have the metadata. This is going to be input dot metadata, comma, and finally we have age rating for the story is going to come from the input dot age rating. And we also need to specify the ID of the story. So I'm going to say new story. The ID is different because it's unique. So I'm going to put it outside of there. And I'm going to say, okay, new story ID is going to be whatever MongoDB specifies for it. And the field for that in MongoDB is _ID. Let's take a look at that in MongoDB as well. There we go. So whatever MongoDB gives it, that's going to be the ID. I don't want to talk about it. I don't want to worry about it. And finally, this is something that has to do with our database, but we need to specify what user is going to get as well. All right. What do we send to the front end, aka our Apollo Sandbox, right? So what is the response? The response is going to be return new story, whatever the user has created. Now, before sending the response to the front end or our sandbox, we need to save it in our database as well. And that's going to be the await new story. And if you want to save it, you're just going to call .save. And yes, this .save is a MongoDB specific syntax. It has nothing to do with JavaScript. It looks like JavaScript because MongoDB has been set up very well to work with JavaScript and this entire JavaScript ecosystem, right? So we save the story just to make sure it's persisted. And then once we get the data and save it in the MongoDB, we send it to the front end. And that's going to be the return new story. And now we can actually go ahead and test this mutation. So let's save this. We don't have any errors. That's a good thing. So how do we test the mutation? Well, we have already done some mutations. Create story mut. There we go. So how do we do this? I could say new story. Let me change these. I'm going to say new story stored in our DB, right? And this is going to be some story, right? Voted status is going to be false. I'm going to keep the metadata and the age rating. I could say 21, whatever. And then what we actually require back as our response is going to be the ID, the name, description, voted status, basically everything, right? So let's go ahead and let's run it. And there we go. So we created a new story whose ID ends at DC65. And here are the data. So let's take a look at our database. So far, our database contains only 20 entries. Our collection contains 20 entries. As soon as I refresh that, you can see now it contains 21 entries. And the ID was created specifically by MongoDB. And here it is, DC65. New story stored in our database, some story false. We have the array, we have the age rating. Let's take a look at the metadata. We have one object, we have the theme, adventure, genre, fantasy. Very cool, right? So this is how you actually make sure that you can query data from your database, and you can also create new data on the database. Now, what I want to do next is I want to give our our GraphQL API some more capabilities. So at this point in time, we don't have the capability to load all of our stories. We can only load one story per one request, right? And for that specific story, you need to provide the ID. We've already done that. So you say get story, you provide the ID for that story, and then you specify which fields you want. You want the ID, you want the name, the description, whatever. But how do you actually get all of the stories? Well, we can do that as well. So if you want to load all of the stories, that's going to be a query as well, right? It's not going to be a mutation. It's just going to be loading some data. So I can just write it inside of the query. So the first query is here, get story, and I'm just going to go down there and I'm going to say, that's going to be, the first one is get story. That's going to give me one individual story and I need an ID for it. This is going to be get all stories. But if I want to get all the stories, do I discriminate among the stories by their IDs? No, I don't. I just want all of them. So I'm going to say async, again, talking with the database. And I do not ask anything from the user. So as soon as user does get all stories, they're going to receive all of the stories. But we need to store them somewhere, right? So I'm going to say const stories, await stories dot find. There we go. And finally, what do we return to the front end? We return our stories. Or I could just call it all stories. That's better, right? So this is all of our stories. Capitalize this S, and there we go. So this is going to give us all of our stories, but then we need to specify this inside of our schema as well. As soon as I save this, you can see the application is going to crash. And here, let's jump into our schema. This is going to be get all stories. Now, why do I put it inside of this type query, inside of the query? Because we just load the data. We don't change the data, right? We just load all of them. When you load the data, it doesn't matter if you load 5 of them, 10 of them, all of them, 1 of them. All of them are going to be the get HTTP method or querying in GraphQL, all right? And if you want to load all of the stories, what is this get all stories going to return? Well, it's going to return, remember, an array of story objects, right? And that's it. So let's save this. Hopefully there are no more errors, and then we can just move on. So let's test our query as well in order to get all of our stories. And let me take a look at our documentation. Let's go to root. Let's click on query. There we go. We have this get all stories, and that should give us the story, all of the data for the stories as well. Very good. When we go to here, we already have a mutation. Let's click on query, and we're going to modify this. So we have a query. This is no longer going to say this. It is going to say get all stories. And what do I want to get from all the stories? I want to get the ID, the name. You know what? Let's just get the name first, right? Just run it. And there we go. We got an array of objects. That's why we specified an array inside of our schema. We said, okay, we want to get an array of story objects because we know that our stories are actually objects. So here are all of the story names. And you can see how powerful GraphQL is. It just gave me the names, very fast, very non-complex, all right? I can just say, okay, give me the voted status as well. And then now you can see, okay, oh, these stories have these voting statuses. You can say, okay, give me now the age rating. Okay, very good. So this story is this, and this story is this. And you can incrementally get more data. And now give me the description. And now you get more and more data. And now give me the metadata. For metadata, you need to specify at least one field, but I'm going to specify both of them and run it, and that's it. So you get 20 stories and all of the data that you want. Very good, right? Now, the only thing left for us to do here is to actually go ahead and implement 2 mutations. One of the mutations is going to be able to update the existing information for an existing story. So the information of an existing story. For example, if I go to the top, I'm just going to give you the first story as an example. Let's get rid of these. There we go. I need to have another curly brace. Let's run it. So this first story, you can see it says voted status is true. Perhaps I don't want this to be true. I want it to be false. And I want to change this data. So that's going to be the update mutation. So the first thing that I'm going to do is I'm going to jump into our resolvers and I'm going to update our resolvers. So we have one mutation that is called create story mutation. I could basically collapse that, right? Or I could just keep it open. So where this mutation ends, it ends on line 31. I'm going to hit 2 enters. And on line 31, I'm going to create a new mutation that is going to be update story. And I'm going to call this mut just to stay consistent. So if I want to update any story, what is the first information that I'm going to need? Well, I need to have the entire story's information. Why entire story? Because I don't know which part of the story user is going to update. I don't know if user wants to update the name or description or voted status or metadata or age rating. I have no idea. But what I do know is I need to provide the capabilities to the user in order to be able to update any part that they want. So I need to handle that, right? So this, since I'm talking to the database, this is going to be an async operation, and we're going to have the ID as the first field. The second field is going to be the actual story itself. So what do we do inside of here? Well, we need to have a container or a variable to hold the updated story information. And I'm going to call that updated story. Why do we need to store this? So we can send it to the front end as a response, right? So we're going to say await stories. This stories is the stories that we actually exported from our DB connectors. This is that collection that we created, all right? So this is this one, which contains our schema, our database connection, everything, all right? So stories, and now whenever I'm updating this database content, keep in mind, I'm updating one story per one call, right? That's the capability that I want to provide. So as soon as I do dot, these are MongoDB operations, MongoDB methods. MongoDB has something that's called find one, and update. And we're going to use that. So which one do we want to update? Well, it depends, right? We first have to know what the ID for that story is. So the ID comes from here. We're going to say ID. And where is the ID actually coming from? That's something that user will have to provide. User has to provide the ID so we can target the correct story. So that's going to become from input.id. Input is whatever user inputs in their GraphQL query, right? So ID comes from there. And then what do we want to change? Well, I don't know. So I'm just going to put in the input. And if user wants to change something that doesn't already exist in our database, we could say, okay, just create it on the spot as well, right? So I'm going to set new to true. So if user accesses an ID for which a story doesn't exist in our database, and user says, okay, this is the current information, this is the name, the description, the voted status, the metadata, and the age rating, we are going to create a new story. But in case that story exists, we're going to modify it, all right? That's what this new true basically means. And finally, we return that as a response to our front end as well. So this is the updated query. Of course, our application is going to crash because we have not updated our schema. So let's jump into schema. And since this is a mutation, we already have this type mutation. So this is going to be update story mut. We are going to select an input. The type of that is going to be basically the same thing that we have here. So let me just copy that and put it right there. There we go. Let's save it. The error is gone. Let's go ahead and let's take it for a test drive. All right. This is going to be a mutation. Since we don't have this, I'm just going to write it by hand. It's going to be update story mut, update story mut. And let me provide the input and then this. Let me get rid of these other curly braces and there we go. So what am I going to provide? Well, I need to specify which ID of the story it is that I want to change. So I'm going to select our latest entry, right? And this, you know what, for update, the example that I gave was this first one. I said the voted status is true. Let's set it to false. So I'm going to select this one. I'm going to say, okay, this is the ID of the story that I want to change or make changes to. And which part of the story do I want to change? Let's say I want to say, okay, voted status is set to false. And do I want to get some data back? Yes, why not? I want to get the name of this so I know I'm correct and the voted status. Required, what seems to be the problem here? I believe the syntax is correct. ID, voted status. Yeah, this ends here. Update story mut. Let me just cut these two lines. I'm going to delete these. Let's just put it up there. Let's put that there. Should be okay. And we get the name and we get the voted status. Let me read this more carefully. Field story of required type was not. Oh, we need to provide the metadata. Sorry. So metadata, genre, and what am I going to write for genre? Let's say updated genre. This is the problem. If you make something required, you need to put it actually there. So I'm just going to say genre is updated genre and metadata. Let's just get the genre. Let's run this. And there we go. So we changed the voted status from true to false, and we also updated the genre, and we targeted the correct story. So if I come right here, and if I try to reload the page, there we go. You can see the voted status is set to false. And the genre, it says updated genre. And in the process, it got rid of the theme as well. So this is how you do update mutation. And finally, let's talk about a delete mutation. So here we have our update mutation. The delete mutation is going to be almost the same, but of course it's going to be delete, so it's going to be different as well. But I'm going to type it anyway. So we have the parts that are similar is our async, and then instead of specifying, okay, I have an entire story, we just want to select, or we just want to get from the user an ID. And whenever a user passes an ID, that's going to be the ID of the story that user wants to delete, right? So we need to have the ID. And the ID is going to be destructured here. How do we do this? Well, we say, now, here I'm not going to store any story. So in the update, we actually stored the updated story inside of this variable, and then we return it. Why don't we want to store anything here? Because we don't have anything to store. So user provides an ID, and user wants that story to be gone. So what is there for me to store? So instead of doing this, I'm just going to do the await stories dot. So what is the method that we're going to use? Well, we have this find one and delete. These methods, you can see they're very, very self-explanatory and easy to understand. So this find one and delete is going to find one story. So we don't allow users to delete in one query their entire database. That one we leave for AI for us to do. But we just want to have users to pass in one ID for one story that they want to get rid of. And that ID is right there. And since we don't have any story to return to the front end, what is it that we want to return? We need to return something to the front end indicating that the operation that they sent as a request was successful. So I'm just going to say the story is successfully deleted. There we go. And let's save this. Of course, the app is going to crash. We need to come to our schema and we need to add that here as well. So this is going to be delete story. And what do we have? The input is going to be, the parameter is going to be ID, and that's going to be the input. But we want to make this required. Remember, so if user doesn't provide an ID, how do I know which story user wants to delete? So this is going to be a required ID, right? And what is this function going to return? What is the return type? It is not a story, it's a string, remember? Here I just returned a string. And delete story, this is going to be delete story mut. Save that, there is no errors. Let's come right here and let me get rid of all of this. This is going to be delete story mut. And we want to test our query, so we don't need all of this here. And we just want to provide an ID of a story that we want to delete. So which story it is that I want to delete? That's the one that I want to delete. So I just selected the ID and I'm going to put it right there. Let me just, it is DC65. Let's run it. And there we go. It says data. The result of this delete story mut is the story is successfully deleted. And now if I come to my database, refresh this, you can see now we have only 20 entries inside of our collection. And with this, our entire GraphQL, Apollo Server, and MongoDB first steps video has come to an end. We talked about a lot of things. Just as an overview, we talked about queries. So let me just show it to you in code. We started with queries with custom type definitions, right? And we said, okay, this is our custom type definition. We incrementally added to this. Initially, we just had the ID, the name, description, and the voted status. We added the metadata, and we added the age rating. We said, okay, how to make something required using this exclamation mark. And then we specified the query for that. So this custom type definition, this is just a type definition. It doesn't specify what user can query. What is the query name? The query name was story, and successfully after that, the queries that we created was to get any individual story from the database, to get all stories from the database, and after these, we needed to have the functions specified for these queries as well. This is the get story that is going to get one story from our database by its ID. This was the function that would get all of the stories from our database. And we didn't have any ID because we don't discriminate against stories by ID. We just get all of them. And when it came to mutations, we had 3 different mutations. One mutation was and a mutation is whenever you change some data, whether that is deleting it, creating it, or updating it. Mutations are like the post, delete, update, HTTP methods, and queries in GraphQL are like get methods in HTTP. So a get method could get you one story, and a get method has the ability to get you all the stories. And a mutation has the ability to delete a story, to update, or to create a new story, which is exactly what we did here. Here is inside of our DB connector, we have our entire logic for our MongoDB setup. And of course, we did all of this using Apollo Server, which made it really, really simple. So that's like a general overview of what we did. So now, and I'm sure this GraphQL Apollo Server MongoDB is crystal clear at this point, and you know the basics, you know how to get started with it, to create simple projects. You can see I'm showing you very simple projects and not too complicated. Perhaps complicated projects are going to come in the future. I want you to actually get your hands on the keyboard. I want you to start coding, and don't make too big of a deal out of this. Just go ahead, get started, create a simple Apollo server. It is right in front of you. You can change this idea to anything you want. You can make it several times more complicated than this, and I encourage you to do it. You can add the schema, the resolvers. Now you know the relationship between schema and resolvers and how all of this factors into our MongoDB. But at first, you don't need MongoDB. You can just have everything in your resolvers and your schema, and later on, if you want to add persistence, you can just go ahead and add MongoDB for that. All right, so just go ahead. I encourage you to go ahead and get started with coding and just create a couple of projects, a couple of backend APIs. So what you can call these is basically a backend API that does not have a front end. All right, the front end could be any technology. It could be Svelte, it could be React, Next, whatever. It could be even pure JavaScript or TypeScript. All right, that doesn't matter. But make sure that your API is fast, it is working correctly, and each time you query for data, you get the same result. You don't get unexpected results, all right? And I really enjoyed creating this project, this API, and I enjoyed even more teaching it. See you in the next one.